I'd like to ask you how old this rock is, and this particular one is a mixture of all kinds of processes, but let's assume for argument's sake it's sedimentary rock. How old is it? Well, what would science do to tell you how old it is? Well, you say carbon dating. Now, you can't use carbon dating on sedimentary rock because carbon dating doesn't go back far enough. And you can't date sedimentary rock in the first place. So if you cannot date it, how old is it? Well, you don't know how old it is. The only thing you can date is igneous rock. And you can use processes like uranium-lead dating, you could use potassium-argon dating, and you could use dating techniques like that to say how old this rock is. Now, how old is it? Well, as old as, let's say it's igneous rock, and you can date it by uranium-lead dating, or one of those techniques, then how old is it? You still have to use the technique. And the technique tells you, after you've used it, that this rock, for argument's sake, is 350 million years old. How do they get to that date? Well, they have to make some basic assumptions. They have to assume that at one stage, all the uranium in this rock started decaying to this isotope of lead, and eventually you have this isotope of lead in there, and there's a relationship between the amount of uranium and lead in this rock. Does that make sense to you? Okay. So, if I want to know how old this rock is, I must know some basic things. If I want to know how old any one of you is, what must I also know about you? Well, I can't tell how old you are until I know when you were born. So how do I tell the birth date of this rock? Well, I cannot because it's after the fact. I'm looking at the rock. So I have to assume that in the beginning there was no isotope of lead from the decay of uranium. So the lead was not there, the uranium was there. Right? So I have to assume that the clock was set to 0 so that there was no isotope of that particular lead in this rock. So 2 pointers. There was no isotope, and it was set to 0. Good. Now, if I want to know how old it is, if I want to know how much time it takes to set a sand clock, you know, I set one of those eyeglass timers, those egg timers, then I know it takes X amount of time for the sand to run from the top into the bottom. Is that right? But what if I had a hole in the top and somebody sneaked more sand in there? What would happen then to my clock? That would be a problem, right? Or let's say I took the time that it formed the bottom to come out the bottom, and I had a certain weight down there, and I knew that much time was passed. What if somebody put some more in there? Would my clock be accurate or not accurate? All right, rock, like this one that I have over here. What do you think? Do you think it's totally impervious? Do you think it's porous? All rock is porous. Well, unless it's vitrified, but it's porous. That's why mountains can absorb huge amounts of water, and springs can run even in the driest season. Is that right? So rocks are porous. All right. Can I guarantee that nothing ever went out of this rock? If I have rain, and the rain runs through the rock, can the rock elements be dissolved in the rainwater, yes or no? All right, let's say I have acid rain. Do you think some of the heavy metals can be dissolved out of the rock, yes or no? So if I have a whole layer of rocks, and I have acid rain going through it, is it possible to wash some of the lead out of the top, yes or no? Where would most of the lead go then? To the bottom layers. So I take this layer and I send it to the lab, and they say, "Oops, there's a lot of lead in here. This is one old rock." Or I send this one to them, and they say, "Well, there's not such a lot of lead in there. This is one young rock." Would they be right? No. Would it be logical? Absolutely, but it would be absolutely wrong. Because I cannot guarantee that nothing ever went into the rock from a layer above. I cannot guarantee that nothing ever went out of it, so that there was a hole in my sand clock or a hole in the top of it. I cannot guarantee any of it. So how old is the clock? How old is the rock? Answer? I don't know. Finished. I don't know. I haven't got the foggiest. Okay. Having settled that and washed off some of this dust from my hands, let's talk about God and science a little more. Now, we discussed the rocks, we discussed the layers. Do I know how old these layers are? No, I can conjecture from being close to a rock layer that's igneous and timing and dating techniques how old it is, but the dating technique has so many assumptions that it's not really valid. I cannot use it, so I don't know how old the rock layers are. All right, so how do I know how old they are? Well, science uses the law of fossil correlation in sedimentary rock. So, for example, you go to a rock layer, and you find this fossil. And you go to another area, and you find the same fossil. Then what do you assume? That they are the same age. So how old are they? Well, they're as old as the fossil within them. So this rock over here is as old as this fossil, and this fossil over here is as old as this rock. And because this fossil over here is as old as this rock, therefore this rock is as old as that fossil, and this fossil being the same fossil as this fossil is therefore the same age as this fossil, and the rock within it is also, around it is also the same age. How old is it? I don't know. I cannot tell you how old it is. So there's no way I can tell the age of the rock from the fossil within it. It's not logical. And by the way, is it necessary that the rock is the same age as the fossil? Is that also logical? Well, it could be logical, but is it necessarily right? Of course not. If I have a dog or a cat and it dies, and I bury it in my back garden, is the dog and the cat then as old as the sand that I bury it in? Well, yes or no? Of course not. So I cannot even say that the thing buried in there is as old as the rock. I might say that it was covered at the same time that that thing died. Does that make sense? That makes sense, okay. So I cannot really say how old it is. Well, let's go to an old geology book, Dunbar, Historical Geology, just to show you this isn't a new notion. That's the same in the new one, so it makes no difference. If covered by moist sediment, weathering is prevented, and for these reasons, quick burial is perhaps the most important condition favoring fossilization. Quick burial. Question: what buries a dinosaur quickly? Unless it is some form of catastrophe, isn't that right? So let's figure out some of these things. Here you have an interesting fish. It has scales on it, but it doesn't have a head. Now you might think this fish was in the French Revolution, and that's why it doesn't have a head. But there is another solution for it. The ligaments on the back of the neck holding a fish's head are one of the first things to rot away. So in fact, if you have a lot of dead fish, one of the first things to drop off is the head. The scales also, when the fish starts putrefying, start dropping off. So you can actually determine more or less how long this thing has been floating in the water. And this one over here was floating a while because the head is gone. And science will tell you that fossilization is actually a chance process over, millennia, millions of years. Here and there, something will fossilize. So that, for example, this is typical textbook stuff. You have some dinosaurs, a volcano erupts, they get buried in the volcanic ash, and then there is some sedimentation or more volcanic eruptions, then erosion, and up they come, and there you have the fossil. But we saw that the majority of fossils are in watery sediments, water sediments. And what is even more interesting is the fossils are orientated. If you go to the Karoo and you look at the fossils of the dinosaurs, and that's the best dinosaur area in the world, then you will see that the dinosaurs are lying in a particular direction. Now, you could assume that whenever dinosaurs died in the past, that they always fell over in the same way. That's a possibility. But there might be another solution, and that is that they are stream-orientated. Do you think that sounds logical? That they are stream-orientated, that they are washed into position. Now, this particular one over here is a fish with huge bony scales, and that is considered very primitive. So science has this notion of saying things are very primitive when they look like that. Now, a sturgeon, which is the one that produces caviar, that fish, has the same bony type scales on it, huge bony scales. Therefore, it is considered a primitive fish, but it lives today. A rhinoceros is considered primitive because of what it looks like. Does that mean it's primitive? It's a mammal. It can't be that primitive. It must be one of the last things to have evolved. So this notion that a thing looks primitive doesn't necessarily make it primitive. We find scales in the fossil record. Sometimes whole rock layers jam-packed with scales, like in this formation over here. They don't form today. Nothing like that happens today because scales dissolve in the deep oceans that we have today. They don't form. You won't find them in the bottom of the mud. This one over here, you find a little fish, obviously slightly putrefied while buried. Here's another one, not so putrefied. Look at that one. This is an absolutely immaculate fossil. There is nothing about it that shows any form of decay. It is absolutely perfect. This fish was swimming along happily when it was struck by a turbidite. It was an instant fossil. Otherwise, there would be some form of decay. Perfect. Instantly cut off from oxygen. This is catastrophism. It's the only thing that can explain it. Scientists will say, hang on a second, we only find certain fossils and others are missing because the soft stuff all didn't fossilize. Well, here is a nice jellyfish. That's pretty soft stuff. There are lots of soft-bodied fossils, perfect ones. So that isn't something that you could use as a solid argument for long periods of fossilization and missing fossils in the fossil record. Here you have an insect. This one has a straight wing, as you can see. Now, insects with straight wings are considered primitive, like dragonflies. And yet scientists studied the dragonfly for years to figure out how to make a helicopter, right? It is so complex in what it does. Why is it primitive? Because it has a straight wing. And beetles can fold their wings, so that's more advanced. But those insects which have straight wings and those which have folded wings occur in the fossil record at the same time. Evolution of Life by Olson says, time and again wind, water and ice have cut and destroyed rocks that have been elevated to form continents. That there is a fossil record at all seems rather remarkable. Imagine now, you are lifting up a continent and you are rubbing out the top. Eventually, you will have rubbed out all the layers, is that right? And you should come to the bottom. Now, in mountains, for example, take the Himalayas. They're being washed away at 6 feet per 1,000 years. So they're getting flatter and flatter and flatter and flatter and flatter. And science says they're still there because the rate of orogeny, the uplift from the continents pushing together, is keeping pace, or maybe even exceeding, the rate at which it is rubbed out. So eventually, you get to the point where the mountain is still there, but the top has been rubbed out. But the problem is, the layers are still there. I can't rub out the top, lift up the bottom to still have the mountain, and still have all the layers on the top that I've rubbed out. Does that make any sense to you? Can I rub out the layers, and then the layers are still there? Hello there, why are you still there? You've been supposed to be rubbed out. You can't have your cake and eat it. You make sense? Okay. Now let's get to this notion that evolution took place over millions of years, and that creatures evolved one out of the other, and that each group evolved into another group over millions and millions and millions of years. That is what science teaches. But the fact of the matter is that it is a totally different picture. Here, Time magazine picks up from the scientific literature of the day and it runs with an article called Evolution's Big Bang, and subscript, evolving at supersonic speed. Now this is a bit problematic. When life exploded. Well, let's go to the scientific source. Here is Scientific American, and here is this article that Time magazine picked up, The Big Bang of Animal Evolution. And just to put the credentials into place, the author there is, as you see, Jeffrey Levinton, and he received he is actually the chair of the Department of Ecology and Evolution at the State University of New York at Stony Brook. So he's an evolutionist, an evolutionary scientist, a very evolutionary orientated magazine. Surely they should have the current picture in place. He talks about the Cambrian explosion. Now remember, the Cambrian is that layer at the bottom when the first macrofossils formed. It says it was characterized by the sudden and roughly simultaneous appearance of many diverse life forms some 600 million years ago. And then he continues to say, talks about a standard evolutionary tree. A standard evolutionary tree rather than what appeared to be an evolutionary lawn consisting of many roots back to unknown common ancestors. Let me put that into position. Science says you start with one organism, it evolves into more and 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 more. So eventually you have a narrow root and a stem, and eventually all the organisms that we have in the world today. Is that right? That's what science teaches. So you started with something like a unicellular animal. You know, we always talk about an amoeba, but of course it wasn't like an amoeba, but never mind, we're not talking science here. So, in that sense, right, in that sense. So here you go, up, 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 more and more and more and more. That's what science teaches. He says, no, we don't have an evolutionary tree, we have an evolutionary lawn. Bum, 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 bum. Everything's there at the same time. It says such stories point to serious problems with all arguments about evolution that rely on taxonomic classification. He says that testing the ribosomes and ribosome RNA from various species suggests that many phyla, wow, now that's a big category of animal, appeared almost simultaneously. Boom. So, according to the modern view of how things happened, the phyla appeared instantly. So in other words, the mollusks, all the snails, the squids, and all these things, they were there. And the arthropods, all the jointed-legged animals, they were there. And so we continued. And of course, science teaches that you started primitive and you went more and more complicated, and way up there somewhere comes us important guys, right? What phylum do we belong to? We belong to the phylum Chordata, chordates. Well, here's an article in the journal Nature, the journal in the world, and it's written by Stephen Jay Gould, one of the doyens of neo-Darwinism. It's titled Of It Not Above It, and he makes this statement: fast turns out to be much faster than anyone ever thought. And then he says this: during the past decade, the discovery and development of another fauna of marvelously preserved soft-bodied Cambrian organisms at Chengyong, China has proven, wow, just swallow this, that full diversity was reached within the explosion itself. We have a problem. He continues to say, all the textbooks proclaim that our phylum, that's the one we belong to, you know, we come way up there in the geological column. The Chordata did not appear until the subsequent Ordovician period, and this later evolution must imply advanced status. So we're the doyens, we're the advanced status. But the Burgess Shale, which is Cambrian, the lowest layer, contains chordates. Wow! Charles Darwin faced this challenge of his gradualistic preference with characteristic honesty. Writing in the first edition of Origin of Species, the case at present must remain inexplicable and may truly be urged as a valid argument against the views here entertained. Question: did Charles Darwin know there was a problem with this already? So everybody else after that has known that there was a problem with this already, right or wrong? I knew. I was an evolutionist. I knew. I was a phyletic gradualist, which means I believed that things developed slowly, one out of the other, but the fossil record didn't bear it out. Everything was dum 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 dum. And right in the beginning, everything, including the group we belong to, was there. And now they're talking about evolving at supersonic speed. Well, what's that other than creation? Right or wrong? It's just one step further from being what they call punctuated equilibrium, long periods, nothing happening, and then there, everything is there. You might as well be creationist. So you don't have these connecting lines. They don't exist. That's what he admitted. He said that there is a lawn, chip, 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 but this common ancestor thing doesn't exist. It doesn't exist in the fossil record. So dinosaurs, did they exist? Well, obviously they must have. We find the fossils. Huge creatures. At the Morrison Formation over here, Dinosaur National Monument, they are digging them out. In the Karoo Basin, they're digging them out. All over the world, they're digging them out. Giant bones, but orientated in stream direction. Sometimes you have what we call strange fossil assemblages, that you have largely one creature, like in this particular one over there in the Morrison. You find this one over here, Allosaurus, largely represented and very few of the others. So it's strange that you should get more of the carnivore. If you go to the museums of the world, this one comes from the British Museum of Natural History in London, you will find their displays of dinosaurs as the bloodthirsty animals tearing and ripping at each other's throats. And they will show you that the dinosaurs ranged in size from very small, something like, just slightly bigger than a chicken size, more or less, to gigantic like this over here, this Brontosaurus. I mean, it's enormous. There's a human being, stretches from way in here in this main hall all the way to the back there. They were gigantic. Or this Triceratops over here, they were huge and they existed. They don't live today, but they did exist then. There is lots of evidence. We find eggs of dinosaurs, and some of these eggs, of course, we'll find them always as surface phenomena. That's very interesting. We'll find them as surface phenomena, but fossilized thereafter. We find footprints of dinosaurs, so they were running. And if you look at them, you'll find that most of them, according to the impressions in the mud, were running upgrade. So we have to assume that in the past, most animals, including the dinosaurs, preferred running uphill. Unless there was some other factor involved. And where do we get footprints from in the first place? Animal running in mud, probably from rising waters, and then a turbidite comes and covers it up. So you have two layers. Then later on, when it dries, the top layer cracks loose, and then you have the print underneath. It's perfect. Sometimes you get the positive and the negative, the fill-in and the bottom. I've seen them all in the world, where I come across them, and they always have the same sort of criteria. Here it says, in this museum, there are over 100 published theories about the extinction of the dinosaurs. So what made the dinosaurs extinct? One of the newer ones comes with this idea: did storms land the dinosaurs in hot water? Well, maybe they did. Maybe the biggest storm that ever struck the planet. How about that? And hot water is not a bad idea, because the subterranean water comes out sometimes at 300 degrees centigrade. So maybe they did land in hot water. Science would like us to believe that meteorites struck the Earth, and that's why you have this iridium layer. And that is what destroyed the dinosaurs selectively. But there's a major problem with that. And that is that in all the layers of the geological column, you don't find meteors. You don't find meteors. You don't find remnants of meteors. And I mean, how much mining has been done in the world up to date? Huge, huge mining undertakings. How much coal has been removed from the earth in strip mining? Huge deposits. You don't find meteors. You find meteors on top. Huge masses of meteoric evidence on top, but not at the bottom. But you know that volcanic activity also produces a iridium layer, and there's lots of evidence for volcanic activity all the way through. Let's just conjecture a while. Why are the dinosaurs not here today? They did exist in the past. We see their bones. Is that right? So why not? Let's try and find some scientific reason. I don't have one, but I'll offer a suggestion. Today we have two categories of animals on this planet, cold-blooded and warm-blooded. Ectotherms and endotherms, we call them, right? Cold-blooded, warm-blooded. If it gets cold, the cold-blooded animal responds by dropping its metabolism and surviving that way. If it gets cold, the warm-blooded animal responds by raising its metabolism. That's you and I, for example, the mammals. And we cope with the cold that way. If you were in between, the one would kill you and you wouldn't be capable of the other. Now, dinosaurs have a bone marrow to bone ratio, which is halfway between the two groups that we have today. And the groups that fall nicely in the middle are the dinosaurs, the mammal-like reptiles, and the flying reptiles. So, is it possible that they're not suited for a post-catastrophic era, for the fluctuations in temperature that we have today, and therefore they are extinct? Just one possibility. All right, here you can see some beautiful plant fossils, and they can tell us a lot too about fossilization. Here you can see some that you can recognize even today, so the fossils aren't so different to what they were like in the past. And if you look over here, you can see over there two coal layers. Notice, please, that the forests were flat in the past, very flat. And there's a typical example of a coal seam that is being removed. Of course, a lot of the coal is considered to be compressed tree debris. So you have a forest growing, tree falls over, gets compressed, forms coal. That doesn't happen today. When a tree falls over in a forest today, what happens to it? It rots away. It becomes energy for the next generation. So this is something else. This is probably catastrophism, because we have trees sometimes the wrong way around. This one is upside down. So this is churning and activity and covering up of huge quantities of plant debris. Stephen Jay Gould says something interesting about the fossil record as well. And notice what he says. Now remember, again, this is the doyen of evolutionary thinking today. The family trees that adorn our textbooks are based on inference, however reasonable, not the evidence of the fossils. If you go into a museum, you will find, for example, the evolution of the horse from the small creature, Hyracotherium it was originally, then they named it Eohippus. Why was it called Hyracotherium? Because it resembled a rock hyrax. And then they will have them all lined up from small to large. And there they are. But remember that these creatures were all contemporaneous. They all occur in the same age strata. So it's like my Martian getting a bag full of skulls, and he takes it to his lab and he arranges them from small to large. Perfectly logical, but not necessarily right. The same way, Gould said, it's based on inference, however reasonable, not the evidence of the fossils. They were arranged according to what we thought the arrangement should be. Does that make sense? Not the evidence of the fossil. They also say, Simpson said, it has been suggested that all animals are now specialized and that the generalized form on which major evolution depends are absent. Let's just put that into simple language. We are told that in the beginning was a simple little, funny little, strange, primitive organism. Is that right? And then later it became more and more complicated. And today we have complicated organisms, right? He says, in fact, all animals have always been more or less specialized, and a really generalized living form is merely a myth or an abstraction. There's no such thing in the fossil record as the simple fellow being at the bottom and the complicated one being at the top. This is important, very important when we talk about the fossil record. So what you see over here is a creature that is extinct today, but lived in the past. But there's nothing primitive about it. This is an extremely complex mollusk, much like a squid. He was folded up in there and jet propulsion, and it was afloat. It was a great creature. Not primitive, this ammonite. There's another one from the British Museum. Here is a trilobite, supposedly primitive. There's nothing primitive about it. It is very, very complicated. So now let's think about this issue. At the bottom of the geological column, I have these so-called simple organisms. But we just saw, is there such a thing as a simple organism? Yes or no? Yes or no? No, there's no such thing. So at the bottom, what do we have? Actually, what we have at the bottom is marine sessile organisms. That's bottom dwellers. If you go a little bit higher in the geological column, guess what you find? You find fish, right? If you go a little bit higher in the geological column, you start finding amphibians. Go a little bit higher, you start finding reptiles. Go a little bit higher, and you find in the top layers the birds and the mammals. So science says the bottom ones, the marine ones, the sessile ones, gave rise to, eventually over time, the higher ones, to the higher ones, to the higher ones, and to the higher ones. Now that is beautifully logical, but it need not be correct. If I have a pond in my back garden, and in my pond I have in the bottom some worms, walking on the bottom in the leafy algae, some snails. Then I have a couple of goldfish in my pond, and I have 2 Muscovy ducks swimming on the top. My neighbor is landscaping, his bulldozer goes out of control. He comes into my courtyard with this huge load and goes and covers my pond. And all my animals are dead. Well, after a while, I pluck up the courage and I start digging this stuff out. And I dig a trench to start off with, so I have a little canyon going through there. And I look, and all of a sudden I see, whoo, this is interesting. At the bottom, there are some worms. A little bit higher, I have some snails and creepy crawlies. A little bit higher, I have some fish, and then I go a little bit higher. Ooh, interesting. Ducks. So I assume the worms gave rise to the snails to the fish, and the fish to the ducks. That would be logical, but would it be right? Absolutely not. But that's exactly what science does. We saw that all the animals appear when? At the same time. There's no such thing as a simple animal. They're all complicated. They're highly complex. And when you look at the ones living today and you trace them back, you will find that the living form looks exactly like the fossil. The living form looks exactly like the fossil in this case of this tortoise. If you go to these creatures over here, the living form exactly like the fossils. In fact, the insects too. I can't believe it, Fred. 60 million years since I've seen you last and you haven't changed a bit. That's exactly what we have in the fossil record. What we see. Did you remember that Levinson said evolutionary law, tip, 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 going back to unknown ancestors? Well, that's what we have here. Tip, 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 and no change. Now, is that evolution, or is that a record of a catastrophe? And the creatures are buried in these layers because that is where they occurred. For example, we have in the ocean today unicellular organisms called foraminifera. Forget about the name. It's little animals like amoeba creatures, but they have a little shell around them. And we have another group with little shells, unicellular ones, which we call radiolarians. And if you go from the top in the ocean to the bottom, they all look slightly different. In the top, there's more light and there's more oxygen. The lower you go, the darker it gets and the less oxygen. So, structurally, they all differ from the top to the bottom. And if you go to the rocks, exactly like they are in sequence today, so they are in the rocks. But because they're different in the rocks, we say the bottom ones gave rise to the later ones. But in actual fact, they look different because of their ecological position. Does that make sense? Birds and mammals always in the top because when they die, they float. we say that mammals are bloaters and floaters. They swell up and they float. So they floated on top and they would be in the top layers. Let's go to an interesting story. We'll talk about petrified forests. If you go to the old textbooks, and this one puzzled me, because some of the old textbooks say that the petrified forests of the world teach us that evolution and not creation is correct, and that the whole question of a flood that destroyed the world is destroyed by these petrified forests. Let me explain to you why. You see, here are trees that are standing upright. So scientists say these trees are in position of growth. They grew there. And you can count their rings, so you can determine that they're old. Some of them are a couple of 100 years old. So there obviously was a period of stability. Now you have an explosion or an eruption of a volcano. The dust settles out, covers the forest. New forest, dust, covers the forest. New forest, dust, covers the forest. New forest. 40 forests sometimes, one on top of each other. And each one with upright trees showing that they grew there. So this sequence of forests must have taken hundreds of thousands of years to form. Therefore, there goes your theory of a flood, 1 year, 17 days. Does that make sense? This is true. So if that is true, then what I'm saying tonight is utter nonsense. So it's worthwhile having a look at some of these petrified trees. Again, please note that the trees are in flat layers, very flat forests in the past. They didn't grow up hills and down hills, but boom, flat layers. Here's one, gives you an idea of the size. They are quite large and they're standing upright. Here's one, and now let's get to some clues. This one over here stretches through a number of layers, so it must be very, very old. And what is also interesting is it doesn't have a rootstock. Can you see that? No rootstock. But what is also interesting is that it doesn't have any bark and it doesn't have any branches. Now, if I'm going to cover a forest with ash, would the roots be destroyed, yes or no? No. Would the branches never be there? No. Would the bark necessarily be gone? No. So what's going on here? Here's one that has been dug out, and you can see that the rootstock is what? Broken off. Now, surely if you're going to cover a forest, an upright tree with ash, then the roots should be intact, yes or no? It should be intact, but they're not. They're torn off. So they have no bark, they have no branches, and their roots are torn. Now, they're not all upright. Here's a horizontal one, a flat one, and here's a whole host of them. There's one over there, there's one over here, there's one over there, looking at one over there. All of these lying flat. And the interesting thing is, can you see that they're all pointing into the mountain? They're all lying in the same direction. So, they're lying in the same direction, they haven't got roots, they haven't got branches, and they haven't got bark. And no matter which level of forest you take, they're all lying orientated in a particular direction. And present-day forests, you have them lying in any direction. Sometimes wind can cause some of them to be more prominently orientated in one direction, but generally speaking, there is no orientation like in these old forests. Another interesting point is, if you're going to cover up a forest, you're going to cover up the floor, right? Here are two forest floors. Over there's one, and there's another over there, just so far apart. Just so far apart. What were two forests doing this far apart? And what is more, if you take this rock over there and you look at it under the microscope, polish it up and look at it, you can see that it's water sorted. Water sorting is a feature, and the volcanic material is brexia, which means it's formed in water. So these forests grew underwater, they were covered by water, and they have no bark, and they have no branches, and they have no roots. And there's a turbidite flame right there, over here. Can you see it there? Whoop, up it goes, and down it goes. So here was turbidite activity. So this was not typical volcanic ash. This was ash that came out of the ground underwater and like a turbidite, rolled across the area. Now it's still very volcanic in this area. There's Norris Geyser. And Mount St Helens gave a tremendous scientific display in 1980 and basically solved this problem. This is what the mountain looked like before the eruption. Please look at the glacier on top. Beautiful glacier. And beautiful lakes around, forests, huge trees, different types of forests. And then there was an eruption of this mountain, but not an explosion, just an eruption. Here is another beautiful lake, Spirit Lake. And then this eruption, first eruption, caused the ice to melt. And it rushed down the south side of the mountain. And there you can see it going, down the south side. And eventually it turned into a major flood on the populated south side of the mountain. And it started tearing out trees, as you can see, ripped them out. And this was a water catastrophe par excellence. And everything on the south side of the mountain. So if you go to these and you go look at the trees and go and walk on them, look what you see. Here are some flat ones, horizontal ones, and they're lying, generally speaking, in the same direction. Why? Because they're water orientated, all right? They've been washed into position. What else do you see? Do you see lots of branches on them? Where are the branches? By the way, do you see many roots? No. Because as they were ripped out of the ground, the roots tore off. And then as they churned in the water, the branches were broken off. And this is a huge one over here that was ripped out by water alone. As they bumped against each other, can you see that dent over there? As these logs churned and bumped against each other, that stripped the bark. And so now you have these trees lying in a direction, just like in the petrified forests, but they have no branches and they have no roots. But that doesn't explain the upright ones. How do we explain those? Well, you see here, this flood was a shallow flood and then whoop, it was gone. But then the mountain did it again. 1 month later, there was a slight tremor, and then, boom, the top third of the mountain shifted, and a huge explosion took place. This is the largest slide ever recorded by scientists. It was gigantic in sequence, and then it exploded with a force of 500 Hiroshima atomic bombs. Boom. And this blast was all to the north side. Now we're talking about the other side of the mountain. There's the mushroom cloud that had formed, and the forests wiped out, the lakes wiped out some of them, and this huge amount of debris falling into the lakes caused giant tidal waves to surge through the area. There's a lake before and after the blast. Boom, gone. This over here is a steam crater. So hot volcanic matter falls into the water, goes boom, explodes. There's a human being over there as an example. Can you see him? Over there. And this steam crater formed within seconds. This is a canyon formed by one of those tidal waves. Just going, washed it out in seconds. And if you look at the layering, well, scientists would have believed it would take millions of years for this to happen. But it happened instantly. This tree was transported upright, look at the top, sheared off by wind. Wind force, blast force. That one transported upright. But the real answer came here. This is Spirit Lake after the eruption. All the trees that had been ripped out, these tidal waves gathered them and washed them back into the lakes. So this is an aerial photograph of all the floating debris. And then if you look carefully, you'll see that very quickly the trees that had a root stump on them, still floating in this water, started floating upright. So they had a look. And what did they find at the bottom? Huge quantities of bark. Massive quantities of bark. Many coal fields in the world consist of nothing but coalified bark. So that explains that. Here are all these upright floating trees. Now they're floating there. And constantly new ones are settling and floating. What would happen if there was another mudslide of proportion and the turbidite would come along. What would happen? They would be buried in position of float. Does that make sense? Okay. Here's another upright one. So they took a sonar and had a look, and every one of those blimps is an upright one. So there were thousands of upright trees floating in that little lake. So if we go to this area and we have a look at the various layers, we find something exciting. Each one of those layers represents one activity, one volcanic activity. In each one of them, you have some horizontal trees, like over there, and you have some vertical trees. Now, imagine everything is covered in water, and some of the trees are floating upright, and some of them are becoming waterlogged and sinking. In this area, there are only 4 eruptive cycles, because you can tell each layer, you can tell by its chemical analysis whether it belongs to one cycle or another cycle. So they know that there are 4 active areas here. So let's assume there's a crack in the ground in that corner, a crack in the ground in that corner, a crack over there, and a crack over there. And that one shoots forth volcanic ash and material, and it goes under the water and goes this way. Which way will the trees be orientated? This way. And then that one goes off and this way. And new trees settle out, new ones are buried this way. That one goes that way, so the trees are orientated that way. This one goes that way, so the trees are orientated that way. And then one after the other, that one goes again, that one, that one, that one, that one, this one, in different sequences. Interestingly, the bottom layer, at the bottom there, and the top layer, just by chance, have the same fingerprint. In other words, they have the same chemical composition. And the same chemical composition appears here and there in the middle as well. Now, we know from studies in Hawaii that the print doesn't change very rapidly, but it doesn't take long to change either. So when a volcano erupts, it draws magma, and when the bowl is empty, the volcano is dormant until it fills up again, and then it goes to a new eruptive cycle. If that cycle is more than 3 months apart, the print differs. So how long for all the petrified forests to form if the top print and the bottom print chemical composition is the same? Less than 3 months. Does it fit into the sequence? Absolutely. It fits into that 1 year, 17-day sequence. In fact, it fits into that first period, that 5-month period. No matter where you go in the world, you will find petrified trees and trunks and petrified forests lying in the same direction. This is in Africa. Here they're lying in the same direction. I measured these forests. I counted them. 95% and more of the trees are orientated. In other words, they were washed into position. Whether it is Europe, whether it is Africa, whether it is North America, whether it is Asia, whether it is Australia, everywhere in the world it's the same story. Are we talking local catastrophe or worldwide catastrophe? We're talking worldwide catastrophe. Tomorrow I'll show you that there is one layer which we call the white band, which is a chalk deposit, which can only form from algae, marine algae, and it stretches across every single continent on the face of the earth. Therefore, how much of the continents must have been underwater at the same time? All of them. Now, if that ain't a flood, I don't know what is. I really don't. Well, here is one of these petrified trees, as you can see it over there. And there's a plant growing on it. In America, they say a plant. Okay. And if you look at it, you'll see that its branches are ripped off. This is in Africa. You will see that it doesn't have bark on it. It's stripped. There's that Welwitschia. And the interesting thing about the Welwitschia is that it is the oldest plant in the world. And you can actually count how old it is from its rings. If you go to your redwood state forest, you can get these giant redwood trees. Now, the interesting thing about the redwood is that it is fire resistant. It doesn't burn. The rest burns around it, but it survives. And these are first generation forests. So by counting the rings, you can determine how old these trees are. When you go to the Welwitschia, when you go to the giant redwoods, those are the oldest living things on the planet. You will see that they are between 4,000 and 5,000 years old. When you go to the rivers of the world, and you determine how long have the rivers been flowing, you will find that they have been flowing on average not more than between 4,000 and 5,000 years. How do we know that? Well, let's take the Nile. They want to build a dam in the Nile. They want to know how long is that dam going to survive. It fills up with silt, right? So it has a lifetime. So if you want to know how long it's going to survive, what must you know? How much silt does the river bring down per year? So they put nets in the river and they do scientific studies for many years before they decide to build a dam. So when they built the giant dams, they put in these sieves, they count determine how much mud the river brings down per year, and then they know the lifespan of that particular dam that they're building. But now, let's take the Nile. It flows into the Mediterranean. There's no great subduction there. There's no place where the mud can disappear under the ground, and it's trapped right there in the Mediterranean. If you take a satellite picture of the delta, and you can determine how much mud has this river brought down in its life, well, it's an easy calculation. It brings down so much per year. There's so much there. How long has it been flowing? 4,000 to 5,000 years. You do it with a Po, roughly 2,000 years. You do it with the Mississippi, Missouri, well, 4,000 to 5,000 years. All the trees, 4,000 to 5,000 years. Isn't that strange? I think it's very strange. Maybe these giant fellows are the first ones to settle again after the flood. So we see fossils in the fossil record. They are sequenced, yes. But their sequence is marine bottom dwellers with a sequence in between. But if we look at the bottom, everything is there at the same time. So now we have an understanding of how that could have formed. We see that it was instant according to science itself. So you have a choice now. You can believe in millions and millions of years of evolutionary processes, or you can believe in catastrophism. And the model that we have presented, in my opinion, fits the data. So there is nothing to be ashamed of if you wish to believe that model. And you do not have to feel intimidated by the other models which rely on millions and millions of years of sedimentary processes. I'm not here to ridicule one or the other. I'm here to set an alternative. In the schools of this world, are we set alternatives, yes or no? If you want to go and vote for which party will run your country, how many parties must stand in the election before it's worth your while going to vote? 2. If there's only one party standing, what's the point in voting? Isn't that right? Okay. If you only get one set of data on which to base your faith, and you never are exposed to another set of data, then everything that you believe and think, your paradigm is set by the data that you are presented with. And I don't believe that is fair. So I'm not here to ridicule one or the other. I'm here to set an alternative, to present another view, to, if you like, put another political party up there for you to cast your vote for, the one or the other. It's a question of choice. That's the beauty of mankind, freedom of choice. And as we continue this series, you will see that the plot thickens and that you have far more to base your faith on, and your choice becomes so much more grounded that you have to have nothing to be ashamed of to believe in the one rather than the other. Christians right throughout the world are intimidated by science. They're intimidated by the school system, by the universities, by the media. And they have nothing to be ashamed of, because there is a perfectly plausible alternative model which they can believe if they have the choice. So bring some more folks. Let's talk about choices. Tomorrow we're going to talk about evolution of man. We're going to talk about woolly mammoths. We're going to talk about how animals could have fitted into an ark. All these interesting questions. We're going to talk about different races of man, different races of organisms, how it all happened. And see you again tomorrow night. Thank you very much.